analysis, how it helps. So today we will be beginning the next part of our syllabus, that is the third module. So in the previous class I have just given you a glimpse of the third module. So today we will get into the details of that. So before we begin into the third module, so let me tell you what is you will be covering in the third module the simulation concept, why you go for simulation, what is the advantage, and is there any drawback of opting for simulation models, and what are the different types of simulation models that exist for any IoT business. Okay, so this is like the topic is quite obvious that any failures can obviously be avoided if you go for a simulation based approach. So little bit about this I discussed with you in the previous class. So simulation solves the problem before they happen. So that is only because simulation is a very easier, friendly, flexible approach where instead of going into the actual implementation in the hardware domain, you do it in a software, you do it in a simulation, which is obviously a cost effective way and a easier, faster way. So you can easily know what will be the outcome if you do this kind of simulation. So if it gets a success, a thumbs up, then you go for the corresponding hardware implementation. So today we will get into the advantages of simulation for any business approach. Like any business, whatever you create, any IoT model, product, or whatever you launch in your market, what are the different kinds of what are the advantages if you go for a simulation based approach. So the first advantage, uh, let me tell you, these are a simulation. What is simulation? So before we get into that, just understand what is simulation. So simulation is a replication of a real world process or event in an environment that is isolated or disconnected from its real world counterpart. So it's not the actual real world thing that happens, rather it's disconnected or isolated from the real world part. It's just on a computer or in a laptop or on a PC you do all the simulation. So it is not anywhere related to your actual world. Rather, it's just isolated, but it is like a replication of whatever happens in the real world. That replication is done in a system or a software. So this concept is best understood. Suppose if I give you an example, suppose there is a traffic system. Suppose there is consider somebody is you are a, building construction engineer or something. You have been assigned to build a bridge at a particular place. So there is a road before that which is a congested road. So what you need to do is you cannot simply send your people or send your employees to that particular place to start building the bridge all of a sudden. So what you need to do is you need to analyze the traffic flow through that particular area. So if you analyze the traffic flow on a software or a simulation based approach, you will suppose make out that during 10 o'clock or 9 o'clock, that's the rush hour of the office or the colleges or schools. So that time obviously you cannot go for that. Suppose after 9 o'clock in the night till 7 o'clock in the morning. So that's the best time when the rush is less. So that time you can afford to use that particular place to build your bridge. So that way, it if you do that simulation thing in a software, like you do all those building construction, because simulation will give you an actual also idea how much time it will take, what problems you will face. So in software, when you go for that simulation, you will realize that this is the best time to do. Like suppose night 9 o'clock to morning 7 o'clock. During that time, I'll build the bridge there, and these are the problems I'll face. So all these details you get to know if you go for that simulation based thing. If apart from that you go build that in a hardware thing and directly in the real world thing, then you will have a lot of issues because you might not be knowing that what is the best time to build, what kind of problems you might face. All these things will be more clearer if you go through a simulation based thing. So there are basically three situations when you want to use simulation. So when will you go for using those simulation based approach. First is when you lack data, which is common when studying ancient or historical events. So suppose you simulation based approaches are mostly used when there is lack of data. You don't have sufficient data to directly go into the hardware implementation. So what you do is you go into the simulation thing, then realize that these are the data missing or I can do without this data. Then you can go for searching those specific data. And when your business process are too complex, okay, so this is also obviously a reason that when it is really very complex, you avoid using it into the like getting directly into the hardware implementation. Next is when you need to experiment in a low cost, low risk environment. So obviously it is a cost effective way because you neither get into directly buying the products or directly getting into the implementation, rather just on a software you do it. Okay. Next is business competitive advantages of simulation. So what are the basic advantages of going for this simulation based approach? The first is flexibility. So it is obvious that you will be having more flexibility because it is just a software. So you can just tweak the parameters, change the circuit, whatever you want. Change the, like suppose you are designing an app, you can just drag and drop the boxes here and there to see how convenient the UI looks. Accordingly, like you can share it among your friends to know their opinion. So everything. But if you do it in a hardware, it will be really tough because the moment if somebody give you some suggestion, changing it actually will take you again months of time. So but best way is like go for a software or simulation based approach. So that gives you flexibility. The next is test large and or complex system. So this is also obvious that you can test large systems where lot of investment is associated, lot of resources are associated. So instead of going into the hardware implementation there, you can go for the software one. Like suppose consider the, can anybody tell me which is the busiest airport of this world? Any idea? Can anybody tell me? Do you have idea regarding this? Which is the busiest airport? Yeah, Aditya, are you here? Avinav, can you hear me?
Yes, ma'am.
Have you any idea regarding this? Which is the busiest airport? Okay, anyone else? Shantanu, any idea? Yeah, Shantanu, can you hear me? Ishita, are you there? Ishita Kabra. Ishita Gupta, can you hear me? Karthik? Yeah, Karthik, can you hear me?
Yes, ma'am, I can hear you.
Okay, any idea which is the busiest airport?
No, ma'am.
Okay. So actually, the London airport, the Heathrow airport, is one of the world's busiest airports. So like per minute, you have around hundreds of flights. In just 60 seconds, there are around hundreds of flights which land and take off from the airport. Okay. So the handling of airport there is actually a Herculean task. So if you actually go for introducing any changes there, that will actually, if you do some changes like you shift some particular some particular what do you tell security check-in portal or something to a different place or something in the airport, so the entire like airport system will be completely devastated there because it will take like half an hour or 1 hour to like move something from here to there. So that time like per minute 200 to 200 flights leave there or land and take off. So the moment you like invest some time, half an hour, 1 hour for shifting something, then like entire the airport system will be devastated. So the best way for achieving that is go for a simulation based thing. So what will the simulation tell you? You can know that which is the least busiest hour of the day. Okay, you can make out that. Then the best thing is during that time only you go for that simulation, like that particular shifting and all those details can be known. Like if you actually do the simulation, what is the problems and what, how many flights are actually, how many people are getting affected to get into the flights and all. So all those details will become clearer. So then only you can take a decision like when to like shift and whether it is feasible or not. So all these decisions can be taken there. So next is isolated from the real world counterpart. So as I told you, your simulation is it doesn't is not connected with the real world in practice. Rather, it is isolated. So whatever changes you do in the simulation doesn't reflect in your hardware. Okay, because you are just doing it in a software, so it is isolated from the real world thing. So the and because of that like it is also an advantage, because whatever changes you do, that will just make you understand what is happening, how to change, what modifications do you need, what parameters you need to analyze. So all this will ultimately help you to like make changes in the real world thing. So suppose the way I told you, the closing a road or creating a bridge, like building a bridge, so all those things, like in real world, in simulation, when you do, it doesn't actually affect the movement of traffic in the road. Okay. Next is address theoretical what if questions. So there are so many questions. Like suppose as I told you, the in airport these many flights are there. So what if I move this put like this desk to that side, or move this gate number to this side? So what will happen? So all these theoretical questions with what if question annotation, like what if I do this, what if I do this, what if this happens. So all these things, all the answers to this will be easily answered if you go for a simulation based approach. Next is study the impact of different interrelated variables. Okay. So there are different variables. So how each variable affect the other variable, impact among the variables, impact on the system. So everything will be easily understood if you go for a simulation based approach. Next is time compression. So time compression, as I told you, so this is like if you go for hardware implementation, that might take you years together or months together. Like suppose you are building a bridge, that's not an overnight job. It needs at least 1 to 2 months to do that. So but in simulation what happens is you can have a like understanding of like how the actual output within a fraction of second. Just simulate that, just put the bridge here and see the advantage. Like if you create a new bridge here, all the traffic will be distributed, and like delay by the faced by the people will be reduced. So all these outcomes, the final outcome will be known to you within a fraction of second. So if you go for a simulation based approach, you need not wait for the entire duration, like years or 1 year or 2 year, for the building to get over, for the bridge to get over, and then realize that this is helping the traffic or not. Next is test for complications. So whatever complications exist in the like real world, all those can be easily mirrored in the simulation based thing. Next is suppose these are some more details. So these are the basic 7 advantages of simulation based approaches. So next is these are 3 more like case studies based simulation based things which I'll be telling you. The first is a digital twin. Okay, so what is this digital twin? So before we get into this digital twin, you must know what is there is something called as a whole system. Whole means the entire system. Okay, so what is the entire system? So whole system modeling is an approach of modeling key aspects of a large complicated system, such as the business rule, the control parameters, the key performance indicators, the KPIs that you want to measure. So need not get into the theory, just understand like there is something called as a digital twin. So let me just give you that. this one. So just see, look at this truck. Okay, somebody is designing, want to design this truck. So suppose while designing, if you actually go for putting the wheel, the dumper section, all those things, and then try to build, it will take months together. But if you go for a simulation based approach, so this is the corresponding digital twin of this truck, you can see. So it develops an abstract model to represent existing or planned systems. So this is the corresponding digital twin. So this will, like, if you do it in a simulation, you can check how much weight it can carry, all those details. Like, it will be, you have to follow a proper rule so that you design a proper digital twin which will be exactly equivalent to this. So from this digital twin also you can make out what load it can carry, what distance it can travel, what speed it can travel. All these details will be clearer to you. So now, as I told you, before creating this digital twin, we need to analyze the entire system. Then only we will be able to create the digital twin. So, analyzing the entire system means you have to consider all parameters. You have to consider, like, all the rules, all logical rules. Suppose that you are designing a truck and you need to know the rule that trucks cannot drive at speed, suppose, greater than 50 kilometers per hour in a business or in a mining site, or 30 kilometers per hour. So all those rules also you need to know. So considering every factor together and designing a twin is called as, like, the all the factors if you consider, that is called as a whole system. Whole system means the entire system. So the example of whole system is like you can use it in a healthcare or a hospital institute, a mining operation, manufacturing, supply chain. So everywhere a whole system can be easily used. But for that you need to have an understanding of every feature, every parameter, every, like, thing that affect the system. Okay, so next is, why should you take a whole system view? So as I told you, if you have a whole system view means the view of entire system including all parameters, all features, all things that affect the system, then you can know what actually, like, how the system actually performs. Okay. So that's the best advantage. Next is, if you have the idea of this whole system, then you can go for a digital twin. Okay. Because you know now the entire system in and out, you can easily design a twin. So a digital twin means it is digitally you design a twin. It is not the actual twin you design, rather a digital twin you will design, where is a dynamic virtual model of a process, product or service that enables companies to better understand and predict the performance of the business. So this is the example which I told you. This way you can design the digital twin if you have understanding of the entire system. Okay, like mining, you cannot ride at this speed, you cannot carry inflammable products, all those things. If you have all the idea, you can easily design the digital twin. So the advantages is, if you go for a digital twin, it reduces the downtime. Like, if a device becomes out of order, then priorly in the simulation based thing you can know that. So the downtime, or like the amount of time you waste waiting for the product to get okay, will be reduced, because you can know beforehand that the product will be damaged, so you need to go for a maintenance thing. Next is, plan for future by using simulation, then develop new opportunities. Then all these, like, some advantages of the digital twin. Okay, so if you go for employing a digital twin across a whole system, as I told you, that will ultimately improve the performance of your digital twin. Then some examples of a digital twin I have given, so you can go through these slides anyway. So in the oil and gas industry, in mining industry, like, these are risky things. Like, if you cannot afford to waste time getting into the hardware implementation directly, so here everywhere you go for this digital twin. Next is your the second like, one more example of this entire thing is, suppose, better staffing through simulation. So if you this simulation can be used for better staffing. Suppose there is this airport authority, as I told you, the Heathrow airport. So you cannot, the people who are assigned a particular ground duty or some duty in the airport, so that can be controlled through simulation. You cannot, like, if somebody is actually assigned a job of giving it, like, as we design our time periods in the institute, so that way it is not possible there, because there are like millions of people working there in the airport. So there you can go for that simulation based thing. Next is, there is something called as Alphabot. Okay, so what is this Alphabot? So suppose you go to a shopping mall. Okay, you order something, and there's something called as a Alphabot now. So what it does is, at the back end, it automates specific steps of the online grocery pickup. Like suppose there is something is ordered by online by somebody, so Alphabot, what it will do is, at the back end of this mall, they'll pick up different products, okay, depending on whatever you have ordered, using autonomous mobile carts. So the vehicle is autonomous, there is no driver sitting into that in the car. Rather, those like robotic cars will be moving inside the what do you tell, the outlet of the factory, and they will be collecting all the products. Suppose you have ordered some, suppose mustard oil, or suppose some muesli or something, so that robot will go and specifically pick all those things, suppose refrigerated items or frozen items, all those things, and that will get delivered. Like the robot will get into a like take that to a particular place and give it for packing. So all these things are now, like, this was a simulation based thing earlier. Now this is also getting implemented in real life. So these are some examples of whatever, like, simulation, what is the advantage and all. So the next part is, what are the simulation models that exist. So there are four types of simulation. So today we discussed what is simulation, what are the seven advantages of simulation, what is a digital twin. So digital twin is something which considers the whole system. So then only you can go for a digital twin. And there is something called as a alpha bot, where a robotic like autonomous vehicle is there who will collect all the items whatever you order online, and that will get delivered to a particular place. So that is one example of a simulation based approach. So next thing is, what are the simulation models. Okay, so as per your syllabus, there are different types of simulation models, so we'll be discussing four of them. So you already know what is simulation now. Simulation means you do something as a replica, like isolated from the real world thing. You do not actually do it in real world, rather it is isolated. Then what are the types of simulation models? The first is Monte Carlo, or a risk analysis simulation. Whatever we discussed till now, is it clear? Hello? Yeah, are you all
Yes,
there or
ma'am.
sleeping? Okay. So now the next thing is, the first simulation model is a Monte Carlo, or a risk analysis simulation. So there are the four models which I will be discussing. See, all these models, you need to know where all these models can be used. You need to understand where, like, with examples, how these models can be used in different industries and all. So the only basic concepts you need to understand, that Monte Carlo or risk analysis simulation is a mathematical model. Okay, that's the basic concept. So this is the first model or simulation model, which is a mathematical model, which what it does, it uses empirical data. That means actual data it uses in the real time, like from, it collects data from the real time, some particular object or something. Suppose you are trying to replicate the airport, as I told, simulate the airport of the Heathrow airport. So what you will do, you will need actual data, like how many people are coming, how many flights are leaving, or how many planes are like landing, how many people, like how many people, which a flight baggage will go into which like belt, and all those details you need to have. So that is done in a mathematical way. Okay, that's the only thing. So Monte Carlo, or that risk as analysis simulation, is a mathematical model where you analyze everything based on real data. Okay, based on real data collected from the real world. Okay, so the advantage of a Monte Carlo based simulation is that it provides awareness and a thorough understanding of the potential threats to your bottom line and time to market. Okay, so that's quite obvious. So this is the first approach, that is the Monte Carlo approach, where we just understand this is a mathematical approach. Okay, next is agent-based modeling. Okay, so agent-based modeling, what it can do, it can model people, it can model equipment, it can model anything that come across. So the simulation includes agents' behavior, which serves as a rule of how those agents must act in the system. So it examines the impact of an agent. So what happens here is, here it is an agent-based model. What it will do is, it will analyze the impact of an agent on the system or the environment. Like suppose mm, any kind of modeling where you consider one particular agent or the person as the main thing, and design your entire model revolving around that person or that particular product, that is called as a agent based model. So however, you must draw your rules from real world data, otherwise you will not generate accurate insights. So whenever you are going for this agent based model, you have to specifically select one particular product or agent, and entire modeling of your system should happen with respect to that particular agent. Next is discrete event simulation. This is the third one. So a discrete event simulation model enables you to observe the specific events that result in your business process. For example, typical technical support process involves the end user calling you. Okay, your system receiving and assigning the call. Okay, let me give you one example. So here, suppose you bought something from Amazon, and like you have some problem and you give a call to the customer care. So how much time you wait, how much waiting period, how well they cater to your needs and all. So all these things can be easily modeled using this discrete event simulation. Why this is called discrete event? Because you don't call buy Amazon from something from Amazon entire every second of the day or every minute of the day, and you don't call the customer care every entire day. Rather, sometime it is a discrete event. It doesn't happen regularly. Okay, but in an airport that is not the case, because every time some flight is going, some flight is coming, some people are coming, some baggage is coming to a belt, something is happening in the airport. But if you go for the discrete event simulation, this is the third type, where the things whatever you model is not a continuous thing, rather it happens in a discrete way. Sometimes you might give a call, sometimes you might suppose you order something from Swiggy or Zomato. Okay, so that is a discrete process. It's not like every day, every second of the day, or every day you order that. Rather, once in a while, sometimes you feel like you order something. So that is a discrete event. So the simulation that revolves around these kind of events are called as discrete event simulation. Next is so one more example, good example of this will be your the hospital scenario, where a patient comes to a doctor intermittently. Okay, or if doctor goes for a surgery intermittently, it's not that the doctor operates on the surgery room every time. The fourth one is system dynamic simulation. Okay, so this is a very abstract form of simulation modeling. So unlike agent-based model, in agent-based what happens? You consider a particular agent and design your model accordingly. In discrete event, you consider discrete events and model accordingly. So here what happens is, here the system dynamics does not include specific details about the system. Okay, in agent based there is specific detail about the agent. In a discrete event there is specific detail about the discrete event. But in system dynamics, does not include specific details. So for manufacturing facility, suppose you consider, so this will not factor in data about machinery and labor. So I'll give you more examples. So in other words, the priority is to get aggregate level insights about the entire system in response to an action. Okay, so you don't rely on a specific agent or a specific event or a discrete event. Rather, the entire dynamics is simulated. the entire. So here system dynamic simulation can be easily applied to your airport scenario, because there is always dynamics involved in that kind of a scenario. There is continuous movement, there is continuous shifting, continuous like landing, takeoff, all those things happening. So there you can go for this system dynamic simulation. Is it clear whatever we discussed today? Hello, was it clear or no? Just let me know. Hello. Hello. Are you there or are you
Yes, ma'am.
sleeping?
Yes, ma'am.
Let me.
Uh,
Okay, I'll just give a form so that all of you can answer and we'll end here. Okay. Just given the question so all of you can answer and then you can. In the next lab session, we will go for your reviews. Okay, so the next week, whatever lab session you have, we'll go for reviews.
Ma'am, so today no review, ma'am.
No, not today. Today we'll have a regular lab, but like in next lab session we'll have the review, the project review. Okay, the first review.
Okay, ma'am.
And all of you, all the teams should be ready with your slides. Okay, maximum presentation time is 10 minutes. So your slides should contain your introduction, motivation, and literature review is must. That what other people have done in the similar domain, whatever you are going for, and then what you have planned and how far have you progressed, or what is your actual plan. Then references. That's all. Okay, just 10 minutes. Limit your presentation to 10 minutes and be ready with the slides in the next from next class. Okay. Next class means the lab sessions. In the lab sessions, we'll go for review. Okay, thank you everyone. I'll just end the meeting here. Stop recording and end. Thank you.